In this video, I explain my solution to question 1 of homework 5, in which we are given two density functions, f of x given by this, and the y density given by this, and we are asked to find the density of z given that z is x plus y. You have to use two approaches, the convolution approach and the geometric approach. For the convolution approach, we know that the density of z is given by the convolution of z on x and z on y, which when expanded is this formula here. And then a simple substitution from above gives us this. And then from this we expand each of the terms and we get this. Now at this stage realize that the function is made up of unit step functions, so we manipulate the limits depending on what is inside the integral. So for example, this one here, it becomes from 0 to z. For this one, from 0 to z minus 1. For this one, from 1 to z. And from this one, from 1 to z minus 1, which we do in the next step here. So after that, it becomes a simple integration, which results in a function of this form. So this function of this form, when represented graphically, is simply something of this sort. Now for the next part, we are asked to use the geometric approach. For geometric approach, we know that the CDF of z is given by this formula, the probability that z is less than z, which is the probability that x plus y is less than z. Now for the first region, if z is less than 1, we know that it will be contained in this square of y to 1 and x to 1, because z will always be less than 1. So we have this line here, x plus y is equal to z, with this being z when y is 0 and y being z when x is 0. So the CDF of z is simply the area of a triangle, half base times height, gives us this. And the density is simply the derivative of the CDF, which is z. Now, when we move to the next region, when z is between 1 and 2, we can see that it's possible for z to be greater than 1 on both sides here and here. And so the area is this trapezium, which can be found by finding the area of this triangle and subtracting the area of the smaller triangles. So the area of the big triangle is, of course, height z, base z, which is a half z squared, and these smaller ones have a base of z minus 1, base and height of z minus 1. So we subtract that area here, and we get the CDF of z as this. So from that we get the density of z as the derivative, which is this. Then for the other region, when z is greater than 0, when z is greater than 2, we know that probability will be 1, so the CDF would be 1 as well, and the density, the derivative of the CDF, will be 0. So we have the same function that we derived from before.